All right, guys, are there any questions on any of the assignments thus far? Question over any of the homework assignments? Well, homework assignment, there's only one. So what we're talking about today and starting today is rational expressions. A rational expression is a fraction whose numerator and denominator are not zero polynomials. So we're going to have a variable in the top or bottom or both. So this will be one or the other or both. So we have that. Now the domain, the values that we can plug in for x, the x values of the domain of the rational expression cannot be values that make the denominator be 0. Any value of x that would make the denominator 0 is what we're going to call a restriction. We're going to restrict those values. Those values won't work. Now, a rational expression will be considered simplified in simplest form or simplified form if the numerator and denominator, the top and bottom, have no common factors other than positive or negative 1. Positive 1 because if we factor the 1 out, it's not going to really change it. It doesn't change anything. And if we factor out a negative 1, it's just making the signs change from positive negative or negative positive. It's not really changing anything about it, just changing the signs. So if it has a common factor other than 1, we have to simplify it out. If the only common factor is 1, then we're good there. Now when simplifying, if there's something in common on top and bottom, we cancel it out. So if we let A, B, and C be expressions with B different than 0, C and C different than 0, we can simplify it out. So if we look at this here, what is a C factor in common on top and bottom? Anything divided by itself is 1, so it just simplifies to A over B. Same thing is true with our multiplication with numbers. Because both of these have a common factor of 5, we can simplify it out. It simplifies to 1, divide it out, leaving us with 3/13. We can do the exact same thing with expressions. X plus 3 and x plus 3. Since they're in common on top and bottom, we can simplify it out, divide them out, leaving us with just 4 over x plus 3. Now let's go on and look at the first example, 4 over x times x plus 2. Is there something in common on top and bottom? No. Simplified. It is simplified. Because some might be tempted to want to simplify this 4 and 2, but we can't because the 2 is in the x plus 2. They're connected. We can't just cross those out. This is as simplified as it gets. So we have an x plus 1 and x plus 1 in common. Now I'm going to write this out. We don't have to do this every time. I just want to do this once so we can see it. Because when we multiply two fractions together, we multiply with the numerators. We can kind of break this back apart and say, well, for the top, it's staying the same as 2 times x plus 1. Because if we multiply them together, they just go next to each other. Same with the denominator. We can say x plus 3. And over here, we can have x plus 1. And the reason I rewrite it out like this, because with multiplication, we can break it up into two fractions and put them back together easily. If it was just addition, we can't do this. But with this here, and since we have something divided by itself, this here simplifies to 1, which is really just leaving us with 2 over x plus 3. And that's it. Questions on this here so far? Now, before we move on to the next one, we do have something called restrictions. Because what our restrictions are is that the denominator cannot be 0. We can't have an x value that's going to make the denominator 0. And since we have two things multiplied together, if there's a value of x that will make one of these be 0, it's going to cause the whole thing to become 0. So if we want to figure them out, we can set both of these equal to 0 to see what our restrictions going to be. Yeah, so we can minus 1 here, saying x is negative 1 here, negative 3. So it's telling us that x cannot be either one of these here. Because if x is negative 1 or negative 3, we're going to have a division of 0 which doesn't work. We can't have a division of 0. So those are our restrictions. It doesn't specifically ask for it, but when we're looking at this, and especially later on in the chapters, having an idea of what restrictions are or how to find them is helpful. Now, some books will say that we only have to list the x is not equal to -1. And the reason they say that is, well, where we got the -3 from is still technically in the answer. It's still a part of the answer, so we don't necessarily need to list it because it's still there. The x is not equal to -1, we have to list it because it's simplified out of the top and bottom, so we're listing it to say it's still a restriction even though it's not there, so we need to list it. But no, I'm not going to count this wrong, because I like listing all of them because they're good to have, good to see. Even if it's still there, it is still a restriction. They're just saying if it's still a part of the answer, you don't have to list it because it's there and we can see it. But I still like listing all of them. Might as well. If we're going to list one, might as well list the rest. So that's it for that one there. Questions on this so far? Now, I don't see that we need to do additional ones of those types because we've done those before. They make sense. So let's look at this one here. Now, there's nothing at this point that we can just cancel out because of the addition, or well, subtraction here. X squared minus 4x minus 12, that's one term. X squared minus 4, that's one term. So we can't just start crossing things out. But we can factor. And whenever we factor these, I factor any of these here, I always start with the one that I can factor the easiest, or I see the factors the easiest and go from there. So looking at this here, which one do we think we can factor easier? The numerator or the denominator? Top or bottom? Bottom. X squared minus 4 is a difference of perfect squares, yes? So that'll factor to what? X plus 2 and x minus 2. Difference perfect squared, so we have x and x. 4 is 2 and 2, plus and minus. So that one's not bad. That one's easier to factor. And the reason that this is helpful is because if we're going to simplify, we need something in common on top and bottom. So it's kind of telling me that one of the factors on top is either going to be x plus 2 or x minus 2. It gives me an idea of what is going to be on top or what we need to be on top. And it is possible that we could get x plus 2 and x minus 2 on top. It's not going to happen for this one here, but if it did, it gives us a better idea. Now with the numerator, we don't have a greatest common factor to factor out, so we can look at signs. Since the 12 is negative, the signs are opposite, positive and negative. The factors of x squared are x and x. Now we need to find the factors of 12. We have 1 and 12, 2 and 6, 3 and 4. Which one do we use? 2 and 6, so we get one that matches. 6 would be negative, 2 would be positive. And we can check it off to the side. X times negative 6 is negative 6x. 2 times x is plus 2x, which does give us a negative 4x that we wanted. So we do have something in common on top and bottom. X plus 2 and x plus 2. Those will simplify out to 1, leaving us with x minus 6 over x minus 2. Questions on this here? So what would our restrictions be? X cannot be. Negative 2, yes. So we're looking for where the denominator is 0, yes? So we're looking at x plus 2 and x minus 2, so it would be 2. Because our x plus 2 equals 0, minus 2 would be x is equal to negative 2. X minus 2 is 0, we would add 2. Minus x is equal to 2. So 2 and negative 2. Because we're mainly looking to where the denominator is 0. Questions on this here? Let's look at the next one. Which one can we factor easier? Bottom, what would it be? X minus 3 times x plus 3, difference of perfect squares. Now, there wasn't a greatest common factor really on top and bottom for this one here. So we can go and do our sets of parentheses on top. Plus minus x and x. Now 12 is 1 and 12, 2 and 6, 3 and 4. Negative, 3 is positive, and we can check it just to make sure. X times negative 4 is negative 4x. Plus 3 times x is 3x, which gives us a negative x that we wanted. Now we do have something in common on top and bottom. X plus 3 and x plus 3, which leaves us with x minus 4 over x minus 3. And if we were going to list the restrictions, positive and negative 3. Because for x minus 3, if we plug positive 3 in there, 3 minus 3 is 0, so that doesn't work. For x plus 3, negative 3 plus 3 is 0, so it doesn't work. So these here would be our two solutions, or 2 restrictions, not solutions. Our solution is x minus 4 divided by x minus 3. Questions on this here? We'll look at this one and one more, and then we'll move on to the next type. Now, looking at the numerator, is there a greatest common factor between x and 4? Is there a number that'll go into both? What's the degree of the numerator? What's the biggest exponent attached to a variable? It's got a square on bottom, yes? On top, it's just x, which is to the what power? So the degree is 1, yes? If the degree is 1 and there's no greatest common factor, it's as simplified as it gets. Because there's nothing really we can do to it besides pulling a number out or a variable out, really number if the degree is 1. So that's as simplified as it gets. If we have a power or degree greater than 2 or equal to 2, then most likely we're going to have to factor it in some way, shape, or form. So the top one's just going to be x plus 4. Now the denominator is kind of nice. 16 is perfect square, 4 and 4. X and x, and we have plus and minus. Well, the numerator did kind of give us a hint, x plus 4, because if it does simplify, we need one of them to match it. So these will cancel out, yes? And this is what you got. It's not quite right. Because anything divided by itself is what? 1. So the numerator reduces to 1. This reduces to. So we get 1 over x minus 4. Because when we're dividing like this here, dividing like expressions are going to reduce to 1. Anything divided by itself is 1. Because there's no way we can divide 2 expressions and get 0 unless the numerator was 0 to begin with. And if we were listing the restrictions, x cannot be negative 4 and 4. Because negative 4 would make x plus 4 be 0, and 4 would make x minus 4 be 0. Questions on any of this here? We're going to do one last one, like this here. Now this one here is a little bit different because this is the first one we've had that doesn't have a difference of perfect squares. Now we need to pick which one we think we can factor easier, the bottom. Since the 6 is negative, our signs are negative. Likely factors of the first term are just x and x. Now factors of 6 are 1 and 6, or which one do we want to use? 2 and 3, which one positive, which one negative? Okay. And we can check it. X times negative 3 is negative 3x. 2 times x is plus 2x, which gives us a negative x. Is that what we wanted? Okay. So that's the setup we have, yes? So it gives us an idea of what needs to be on top. We either need an x plus 2 or x minus 3 for something to cancel. Now, it's not guaranteed that we will have something in common. It could be that it's like the first one we did, it's already in simplest form, but we still need to go on and factor it and see. 2 sets of parentheses. Since the 3 is negative, our signs are opposite. We have x and x. 1 and 3 are the only factors of 3, yes? I'm going to write it the other way, but I'm going to fix it here in a minute. Because, I mean, it could be x plus 3 times x minus 1, but it is, if it is that, do we have anything in common? No, because it needs to be negative. So if this is going to work, we need the 1 to be positive and the 3 to be negative to have something that cancels out. Now we can multiply and check. X times negative 3 is negative 3x. Plus 1 times x is plus x. So we get a negative 2x. Is that what we wanted? And since we have that, these will simplify to 1, leaving us with x plus 1 over x plus 2 as the answer. And that is, again, something that we're tempted to do because we've, for so long, have just said canceled out, it cancels out, it divides out. It really simplifies to 1. Any questions on this so far? Not too bad. And again, the setup of doing the easiest ones first and then working their way back from there is going to be helpful, especially when we start multiplying and dividing these polynomial expressions where we're having to factor 3 or 4. It becomes more helpful to start seeing the like factors and matching them up to simplify it down. The next thing we're doing is multiplying rational expressions. So we multiply 2 rational expressions. We multiply numerators with numerators, denominators with denominators, top with top, bottom with bottom. We multiply straight across. And whatever we have in common on top and bottom will cancel out. And here's an example here. Now there's multiple ways that we could go about doing this. I'm going to show you one way first. I don't really like this way, but I want to at least show you so you can see it. And one of the ways that we can do this is rewriting this kind of prime factorization, breaking it all the way down into simplest terms and going from there. So if we did that with 8, well, 8 is the same as 2 times 2 times 2, 2 cubed. X to the third, well, that's just saying that we have x times x times x times y. So if I broke 8x cubed times y, or 8x cubed y, yeah, it's really just breaking it all the way down. 7 is prime. X to the fourth is x times x times x times x. Y cubed, well, that's 2, 3 y's. So we have this. In the denominator, well, 2 is prime. We only have 1 x, and then we have 2 y's. 4 is 2 times 2. Y. Now we can kind of put all these together. So we have 1, 2, 3 2's, and a 7 on top, because we're multiplying top with top. Now we've got 3 x's here. We've got 4 here, so we have 7. So 1, 2, 3, 4, 5, 6, 7. Then we've got 4 y's. 3 here, 1 here, 4. On bottom, we've got 3 2's. 1 from the first, 2 from the second. We have 1 x, and 2 y's from the first, and 1 from the second. So really just merging them all together. Now we can say anything divided by itself is 1. Well, these 3 2's on top, we'll cancel out with these 3 2's on bottom. This 1x on bottom will cancel out with 1x on top. These 3 y's will cancel out with these 3 y's. So what that leaves us with is, well, everything in the denominator simplified to 0, or kind of 1, it canceled out. So there's nothing left on bottom that we have to write in. On top, we still have the, then we got 1, 2, 3, 4, 5, 6 x's, so x to the 6, and y to the first. This is not my preferred method of doing this. The other way we can do it is multiply first. So we multiply the numbers first. 8 times 7 is 56. So we can just multiply those together. Then we do x to the third times x to the fourth. When we multiply like bases, we add the exponents. So 3 plus 4 is 7. We got 7 total. Then we do y to the first times y to the third, which would be y to the fourth. Denominators, do the numbers first. 2 times 4 is x, so we only have one of them. Y squared times y would be y to the third. Okay? Now at this point here, we can simplify. So 56 over 8, we can go through that and do it by hand, or we can say 56 over 8 in the calculator, and it tells us that it is 7. Now, since it doesn't give us the denominator, it's understood that the denominator is 1. So we can put 7 on top. X to the 7th over x. Well, if we're multiplying like bases, we add the exponents. So what do you think we would do if we divide like bases? Subtract, opposite of addition. So we can do 7 minus 1 is, was it the exponent bigger on top or bigger on bottom? So it stays on top. Is how I think about it. And the last one, y to the fourth over y to the third. 4 minus 3 is and it's bigger on top, so it stays on top. And that's it. Because we don't have a denominator we have to write in, it's just 1. So we can just leave it as 7, x to the 6, y. That's it. Both of them get us to the same answer, but they're different ways to do it. Any questions on either of these here? Now, I mean, there are other ways we can look at this, because we know that these are all going to end up being multiplied like this here, yes? And I mean, I can start hacking and whacking away at this to begin with, because I know 2 times 4 is 8, yes? So we know that these 2 will cancel out with the 8. We can say this y and this y cancel. I can say 2 of these cancel out with 2 of those, making that 1. This is going to turn that into a 2. I can start whacking away and simplifying stuff to begin with and then go from there. But this here can sometimes get very messy very quick. So it's figuring out which way you guys like to do it better and then go from there. Now this one here, so we can multiply the numerators first. 6 times 9 is 56. X squared times x to the 5th is x to the 7th. And y times y squared is y to the 3rd. The denominator. 54, yes. Thank you. I think that was the last one that was 56. 54, x to the 7th, y to the 3rd. Thank you. That would have messed everything up. Now in the denominator, 3 times 2 is 6. Then we have x. Y to the 3rd times y is y to the 4th. Now we can do some simplifying. So we can say 54 over 6 is 9. 9, so it stays on top. Because it would be on bottom if we had 1/9. Then it would go the other way. X to the 7th over x. So 7 minus 1 is 6. Bigger on top, it stays on top. And the last one, we have I to the 3rd over y to the 4th. So 4 minus 3 is, it's just y. It's bottom, since it's bigger on bottom, it stays on bottom. There's a set method for it that we would just straight subtract them, which 3 minus 4 is negative 1. So if we just did the subtraction, it would be 9x to the 6, y to the negative 1. To make an exponent positive, we move it from either the denominator to the numerator or numerator to the denominator, from the top to the bottom or bottom to the top, to change the sign. So it just goes back. And for simple ones like this here, if it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. Questions on this here? Any questions over anything we've done so far? All right, we'll do one more and then we'll be done for today. So if we look at this one here, we can multiply the numbers first. So we'll have 3 times 6, which is 18. 8 times 9 is 72. X to the 5th times x is x to the 6th. And y squared times y squared is y to the 4th. On bottom, we have x times x to the 3rd, which would be x to the 4th. And y times y is y. Now we can do 18 over 72 on the calculator. 18 over 72 is 1/4. So we put the 4 on bottom. Now if we want to write the 1 on top, that's fine. But I normally leave it blank till the very end. Because if it ends up being that everything on top simplifies out, then we need to put the 1. But if we still have stuff on top, x or y, then we don't necessarily need to add it. Now the next one we have x to the 6th over x to the 4th. 6 minus 4 is 2, and it's bigger on top, so it stays on top. So since we do have an x squared on top, we don't need that times 1, so we can just leave it as x squared for now, depending on how the last one works. Y to the 4th over y squared, 4 y squared, since it's bigger on top, it stays on top. So our answer is x squared y squared over 4. And that's it. Questions on this here? So what we're going to start with tomorrow are these here. And really for these here, it's not too much different than what we've been doing. We just have to factor and then work it from there.